So far, we've taken notes on page 65 and 66. On 65, we learned the basic tenets of the Pythagorean theorem. Okay, there are two parts. If the sum of the squares of the two shorter sides of a triangle equals the square of the longest side, then we know it's a right triangle. And we know if it is a right triangle, then the sum of the squares of the two legs, the shorter sides, is equal to the square of the hypotenuse. In other words, if a squared plus b squared equals c squared, then it is a right triangle. And if it is a right triangle, then a squared plus b squared equals c squared. Okay? There are basically four parts of a right triangle that involves the Pythagorean theorem. The hypotenuse, the two legs, and the right angle. Any one of these could be missing. For example, okay, we could know the measurements of all the sides, but we don't know whether it's a right angle or not. In that case, we have to find out, does a squared plus b squared equal c squared? On the other hand, we could know that it's a right angle, but we could be missing the measure of the hypotenuse. In that case, we have notes on page 66 that tell us how to find the length of the missing hypotenuse. Okay, the last thing we could be missing is one of the two legs. And this would apply to either one of them. We know it's a right angle, we know the measure of the hypotenuse, and we know the measure of one of the legs. Right? So let's go ahead and copy these notes onto page 67. Again, okay, we want to label all the sides. And remember, C is always opposite the right angle. That's going to be the most important one to label. Okay. Write the Pythagorean theorem out. A squared plus b squared equals c squared. Substitute values for the variables. Square the variables you know and solve the equation for the missing variable. This is going to involve an extra step because we're going to have the variable with another number on the left-hand side of the equation. So we're going to have to subtract that from both sides before we take the square root of both sides. All right, let's do it with this one that we have in our notebook. We know a has to be 3, but let's see if it's actually going to work out that way. Okay, so we start by writing the Pythagorean theorem. We know that b is 4 and c is 5, so we substitute those values in. We square everything that we can square, and now here's the new part. We have to get a all by itself. So this is a two-step equation. So the first thing we have to do is subtract 16 from both sides, which tells us that a squared is going to be 9. Then, in order to find out a, we can take the square root of both sides and get a is equal to 3. All right, let's copy one into our notebook, okay, based on this problem. All right, we know that the long side is 8. The short side here is 4. We know it's a right triangle, but we don't know what this leg is. So first thing we're going to have to do is label, okay, the sides. This side here, all right, is going to be C. All right, that one's A. Okay, we'll call this one B, and then we'll call that there, because it's opposite the right angle, that will be our C. Okay, so again, we're going to write the Pythagorean theorem, substitute in the values for, in this case, A and C, square the numbers. Okay, again, subtract the squared numbers from both sides, and we get b squared is equal to 48. We don't want b squared, of course, we want b, so now we take the square root of both sides, and we get b is equal to approximately, remember it's going to be an irrational number, approximately 6.9. So go ahead, copy this into your notes, right, so that you now know everything that you can do with the Pythagorean theorem.